another problem. This problem actually asked in Microsoft. This is the Microsoft series. So this is a search in a 2D matrix. So what is the problem? Write an efficient algorithm that searches for a value target. So you will be given a target value, and just like this three, and another 2D matrix of m cross n, and you need to find that number into that matrix. So you just need to return like boolean. If that number exists, then true. Otherwise, it's false. So the conditions are integer in the each row are sorted from left to right. These are sorted from left to right at each row. The first integer of each row is greater than the last integer of the previous row. Means if it is 7, the other integer which is in the next row, it will be greater than this one. So it's whole sorted like now row wise and a column wise, and this is the condition. So how to approach this problem? Obviously, there is always a brute force way to do that, like apply two loops, and that will be like m into n. The solution will be this m into n, but we actually can do it better way. So if you see like both are when the array is sorted, obviously we can apply binary search, right? And this is sorted in both the way, like here and here. So what you can do, like just apply a binary search on this whole 2D matrix. So for particular example, we can find the mid for whole the array, like the last of this row, the last of this column, sum of them and half. So your mid will fall around this way, and like normal binary search will compare with the target element, the mid element. If it is fine, we'll return true if it is equals to that element. If not, then we'll just keep on compressing our start or end, depending on the whether the target is greater than the mid or not. So we'll just discard the whole this part if that element lies here, and again the same algorithm will find the mid of this whole this four somewhere around this one this, and based on the condition we'll discard the whole shorter matrix. So the complexity would be your log of m plus log n, because we are applying the binary search in both the directions. Okay, let's get started. First is basic null check, like your matrix shouldn't be null. If matrix is null, or matrix dot length equals to 0, or maybe matrix, what are the element that is present at 0 index is null, or it could be matrix what are the element at 0 dot length equals to 0. In either of the cases we need to return false because the matrix is empty and the number is not present. Now next is we'll get the length. So the m is the length of the each row, so that will be matrix dot length. Similarly, we'll get the column length, so that will be n equals to matrix 0. So now we have this validation that the matrix is not empty, and now we have the rows and columns length of the matrix. Now we'll just do int start equals to 0 and equals to m into n minus 1. Because like if it is a 5 cross 5 matrix, right, your n will be like 5 cross 5 equals to 25 and minus 1, that will be 24. So this is the n index that is already present. So for suppose this is 1 2 3 4 1 2 3. this is 4 cross 3, so m into n is 12, and 12 minus 1 is 11, so the n will be the 11th index. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. This is how we calculated the n. Now the simple condition that we use in binary search, like your start should always be less than or equals to n. And now we'll calculate our med. So med equals to obviously the usual condition, start plus n divided by 2, that is a med. And the temporary is actually the element that is present into this mid index. So for that we will just get the element at med. So this will be med divided by n for the row, and then next is we just wanted the remainder of this, right? So that would be the med modulo, and that's how we'll get our temporary variable, the middle element that is present. Uh, Now our basic condition of the binary search: my temporary is greater than my target, right? So temporary is greater than the target, then actually we need to compress the end, right? The end part, because the uh, whatever I am, the target is smaller, so I just need to go to this part. So I need to compress the later part. So what can I do? I will just decrease my end and just continue from here. If it is not the case, means my temporary variable smaller than the target, right? Then in this case, I'm at this part, but my target relies at this part, so I need to remove this part from the matter. So what can I do? I can just put start ahead, and then just continue. If it is not falling in both of the loops, means whatever the time is equals to the target. So you just return, sorry, so you just return true. If the whole loop is continue and the whole cycle ends, but you you haven't encountered your target and you haven't returned true, then obviously the element is not present, and then you just need to simply return. So the complexity is log m into log n. Just try to run. Okay, we have compilation error. This is okay. This is fine. Let's test for the other cases. Yeah, if this is accepted, we'll check for details. Yeah, it's fine. All the test cases passed.